Hi friends. Now today we are going to discuss about gas turbine with reheating. Okay, gas turbine with reheating. So the output of a gas turbine can be considerably improved by expanding the hot air in two stages with a reheater between the two. సో ద అరేంజ్మెంట్ ఎలా ఉంటుందనేది ఇప్పుడు మనం చూద్దాం. వీఆర్ గోయింగ్ టు సీ ఫస్ట్ వన్ ఈజ్ దిస్ ఈజ్ కంప్రెసర్. So now here this is called first turbine. Okay, see this compressor, first turbine, second turbine, generator. ఇంతకుముందు మనం చూసినట్లు ఒక టర్బైన్ మాత్రం యూజ్ చేసాం. ఇక్కడ 2 turbines we are using. And then now here we see hot air in, hot air out. Now this is 1, this is 2. Then here 2 we send to again here heating chamber. Again here also reheating, then hot air in, hot air out. Okay, this is called 4. And now this is 3. Okay, and now we are going to arrange of cooling chamber. Now this is cooling chamber. This is cooling chamber, and it passes like this. So this is 5. This is 6. Okay, so this is the process. So first compressor nunchi malli 1 to 2, this is coming from hot chamber. In this hot chamber a hot air is in and the hot air is out, and then now here it will come the condensate, and that the compressor air is enter into the first turbine. the compressed, and next the compressed air again we are resent to the heating chamber and to send to the second turbine to run the generator. So this is cooling chamber, and the hot air will cool in here. Okay, so now the process we are going to see in here, two turbines. Okay, here two turbines is there. The process 1 to 2 shows heating of the air in the first heating chamber at constant pressure. So this is heating chamber 1, and this is heating chamber 2. Okay, so now here look at this heating chamber 1. Okay, at the constant pressure. Okay, at the constant pressure, the process 2 to 3, the process 2 to 3 shows isentropic expansion of air in the first turbine. Isentropic air in the first turbine. Okay, and the process 3 to 4, here look at this, the process 3 to 4 shows heating of the air in the second heating chamber at constant pressure. The process 4 to 5 shows asentropic expansion of air in the second turbine. Okay, so the process 5 to 6, it shows cooling of the air in the intercooler at constant pressure. So finally the pressure 6 to 1 shows compression of air in the compression. So this is the diagram for closed cycle gas turbine with reheating. Okay, now we will go to see in here TS diagram for this. Now which see can fix 3 points. Here is the point. Okay, now this is 1 and this is 2, this is 3. Okay, and now here we are going to see again one isentropic. Now we will touch in here the process 1 to 2, 2 to 3, and then 3 to 4. Okay, and then this is 4 to 5. You can draw straight line. Okay, so this is P5 is equal to P6. Then here is going to 0.6. Here to here, here to here, like this. It will going like this process. And then now here is coming from P3 is equal to P4. Then this is P1 is equal to P2. So therefore work done by the turbine per kg of air, that is equal to Wt into Cp T2 minus T3 plus T4 minus T5. Okay, now here is coming from, this is T1 and this is called, here is now this is called T1 and this is T3. Here this is called T4. Now this is T2. You see this is T4, T5, T6, like this. Okay, so this is equation number 1, and work done by the work done by the compressor per kg of air. So that Wc is equal to Cp into T1 minus T6. You can put, this is equation number 2. So now net work available, that is W is equal to Wt minus Wc. This is equation number 3. So here మనం గమనించాల్సింది ఏంటంటే, ఇక్కడ one important thing, the power available or net power of the insulation may be found out from the work available. Okay, as usual, for maximum work the reheating should be done to an intermediate pressure. So that's the thing is here we called P3 is equal to P4, then that is equal to P2 into P5. So that is equal to P1 into P6. Okay, since here P1 is equal to P2 and P3 is equal to P4. Okay, sometimes cooling and reheating is provided simultaneously in gas turbines. So in such a case the corresponding values should be used. Okay, sometimes we are using cooling and heating, both simultaneously we can use in gas turbines. Then on that time we can use in this type of equation. Okay, P1, P2, P3, P4. Okay, now we are going to see in here one problem. So look at in here, in a gas turbine plant, the air is compressed in a single stage compressor from 1 bar to 9 bar, and from air inlet and from air initially, not air, this is, and from air in an initial temperature of 300 kelvins. The same air is then heated to a temperature of 800 kelvins and then expanded in the turbine. The air is then reheated to a temperature of 800 kelvins and then expanded in the second turbine. Find the maximum power that can be obtained from the insulation if the mass of air circulated per second is 2 kg. Take Cp is equal to 1 kilojoules per kg kelvins. Okay, so this is the given problem. Now we are going to see how to solve this thing. Okay, now solution. given P6 is equal to P5, that is equal to 1 bar, and P1 is equal to P2, that is equal to 9 bar. Then T6 is equal to 300 kelvins, T2 is equal to T4, that is equal to 800 kelvins, and M is equal to 2 kg per seconds. So Cp is equal to 1 kilojoules per kg Kelvin. Okay, now we are going to see this diagram, TS diagram. This is called 1, this is called 2. I'm going to fix 3. Okay, so then here is like this. This is 4. And now this is 3. This is 4. This is isentropic process in here. So this is 5. So this is 6. See, this process is here 1 to 2 to 3, 3 to 4, 4 to 5, 5 to 6. And now the process is coming like this. Okay, then T5, T1, T2, T6, and now here this is same, T4 is equal to T2, that is equal to 800 kelvins is given, and then now here is given 300 kelvins. Okay, in problem is given 300 kelvins T6. Okay, and now let here T1 comma T3 comma T5, that is equal to temperature of air at the corresponding points. So we know that for maximum power or work, the absolute pressure is coming from here. P3 is equal to P4, that is equal to whole root of P1 into P6. Then here 9 into 1 is called here 3 bar. So you know, for isentropic compression of the compressor, so isentropic compression, okay, process 6 to 1. So then here 6 to 1, T1 by T6, that is equal to P1 by P6 whole power gamma minus 1 by gamma. And now here substitute the values in here, 1.4 minus 1, 1.4. And then now this is equal to 9 whole power 0.286 whole value, 1.873. So now we need T1, that is equal to T6 into 0.7873, that is equal to 300 into 1.873. So then here 562 kelvins, that is called T1. Similarly, we are going to see here isentropic. Similarly, we are going to see isentropic expansion. Isentropic expansion, that is called turbine process 4 to 5. Here is compressor, here is turbine. Okay, so this This one is coming from here. In turbine we take 2 to 3. Sorry, turbine is coming from here 2 to 3. First turbine. Okay, you can take first turbine. See this 2 to 3 is first turbine. Okay. And then now here we are going to see T2 by T3, that is equal to P2 by P3 power gamma minus 1 by gamma. Then substitute here the values 1.4 minus 1, 1.15, 1.4, then 3 power 0.285, so 286.286, then this is equal to 1.369. So now here we need T3 is equal to T2 into 130 divided by 69. So 800 divided by 1.369 is equal to 584 kelvins. So this is the value for T3. Okay. Now we are going to see second turbine. Okay. Now here we are going to see isentropic expansion process 4 to 5. This is called second turbine. Expansion process 4 to 5 is called second turbine. Then here T4 by T5, P4 by P5 whole power gamma minus 1 by gamma. Then the values you can substitute here. Simply 286, so that is equal to 1.369. Okay, and therefore T5 is equal to T4 divided by 1.369, so 800 divided by 1.369, that is equal to 584 kelvins. So the same value it will come T4, T3 and T5. Now we know work done by the turbine. Now work done by the turbine, Wt is equal to m into Cp, so that is called T2 minus T3 plus T4 minus T5. Okay, now we know all values, then you substitute that values in here. Yeah, so then you calculate this, you will get the answer here, work done per turbine and observed by the compressor. So observed by the compressor, WC is equal to m into Cp T1 minus T6. Then that is equal to 2 into 1, 562 minus 300. So then this is called 524 kilojoules per seconds. Okay. So we also know that work done, W is equal to Wt minus Wc. So 864 minus 524. Then that is equal to 340 kilojoules per seconds. Now we know very well the power P also work done same, so 340 kilowatt, since here joules per seconds is equal to watts. Okay, this is the procedure to solve the reheating problem in gas turbines. Okay, and now we are going to see in next class open cycle gas turbines. Okay, thank you.